And in the supervised learning, we will do two models. One is KNN and one is decision tree. Anyone know any idea about KNN? What is its full form? Anyone? Any idea about it? What is the full form? K nearest neighbor. Excellent level. K nearest neighbor. Yeah. So we will discuss about these two. Full form of Ritvik, I am asking KNN. It's already given. Yeah. No problem. It's not unfortunate, Ishan. I will explain all the things today itself. Right. So are you people ready? Yeah. Are you ready? Okay. Just tell me before beginning with anything. Do you have Anaconda and Jupyter Notebook installed in your machines? Because we will do side by side. Right. I will tell you. Collab is also equally fine. No problem. In my machine also, due to some reason, Jupyter is not working. So I'm also using the collab, right? Spider can also be used. No issue, no issue. Okay, do you have the data with you, Iris? Because you people said you people have done the data visualization. Whatever platform you want to use, Shravan, you can use VS Code as well, okay? But I am going to tell you in Jupyter Notebook or Google Colab. Ideally is also fine, okay? If everything is perfectly installed over there. Okay, do you have that Iris data with you on which you already done the data visualization? No, you don't have. Okay. Just give me 1 minute so that I this is the one. Okay. This is the one, the data set that we are having. Right. Now, can you see here how many fields are there? There are no column headers, but I can explain it to you. We have how many columns? 1, 2, 3, 4, 5. Okay, the first four are denoting the sepal length, sepal width, petal length, petal width. And can you see the last one? It's written Iris setosa. So this is one of the class of iris flower. When you just scroll it down, we can see another name. What is it? Another name. It is Iris versicolor. And when we move it further, we have Iris virginica. So these are the different classes of iris flower. So I think again and again I'm taking the name class. Is anything that you can understand what I'm going to do? Anything that you people are able to understand what I'm going to do? Anyone having any idea? Graph you have already done, Rudraj, so we are not repeating the data visualization classes. So what I am doing a class, creating an AI model that can do the classification. No, I'm not creating a class. Creating a class in C++ Python, that is different. Okay. Yeah, flowers are there. My AI model, whenever I give different values to it, once I create a model. So once I create a model, what I need for training my model? I need a data set, isn't it? So once I train my data with the given data, I train my model. Then later on, if I give any new data to my AI model, it will predict what is the class of that flower. So is the problem statement is clear to everyone? Yes, Ishan, exactly. This is a supervised learning model. So problem statement is clear, what we want to attain? Yes? Okay, great. You can show a thumbs up also. Right? So this is all which is, I have already shared. This is a course notebook. I have shared a student notebook with you all. The introduction is exactly same. If you need more information about machine learning, there are different links which are present over here. Okay. Okay. What is the need of importing the pandas library? Okay. Hitesh is having a doubt. What is the difference between Iris virginica and Iris setosa? These are the different classes of the same flower iris. 3 classes are there, isn't it? For example, sometimes it happens now, the name of the vegetable is same, but it has different types, isn't it? So these are the, we can say, different types of iris flower. screen is visible now? Okay, great. So is it, are you able to understand? Someone was asking me ki what is setosa, what is versicolor, what is virginica? You want me to send the drive link again? Okay, just give me a minute. I want everyone, I'm just giving you here a pause of a minute. Please download. 2 files are there in the drive link. Yes, Ishan. We use the pandas for reading and loading the file, data set. And what is that file? This file is actually a data set. Okay. So first thing is, it's very important to import the pandas library. Okay. If you want to visualize your data by making different graphs, I'm coming to CSV also. Say that, don't worry. So which library we need? Which library we need if I want to visualize my data? Pandas is for data manipulation. Matplotlib, exactly. And if I want to do some numeric calculation, some numeric analysis, yes, then we need a NumPy. Right, exactly. Okay. Now, the file that I have just shown you, can you see? All the data here is separated by comma. Can you see? Is my file is visible to everyone? Yes. So can you see the whole data set is separated by comma? So this kind of file, we call it as CSV. What is the full form of CSV? Anyone? What is the full form? Yeah, it is a quantitative data, definitely. Comma separated value, exactly. So can you see? We can see it's separated by comma, right? Okay. Now, if we are working in Google Colab, okay, if you are working in a Google Colab, what you need to do? You need to upload your file. You can go here on a file sector and you can go there and upload your data set. Now, can you see? I have already uploaded iris.data. You click over here and from here you can select the data set. I have already uploaded. Okay, so for a particular session, I have already uploaded my data. Okay, and if you are using Anaconda and the Jupyter Notebook, then there is no need to open Google Colab or upload it. Just put it in the same folder where you are having your iris data. I hope I'm clear. Yes. If you are using Google Colab, then you have to click on these 3 dots and you can go to cell. We call it as cells only. Ma'am, I'm not able to upload. Okay, I will give you some time to that. First of all, just look at the code part that I'm going to explain you. Okay. Yes, shift, enter. Yes, Levin. So it is here. Everything is explained about the supervised learning, right? There is some video also that you can watch that will tell you more about the supervised learning. Fine. Now let's go to the K nearest neighbor. So first of all, you must know what is K nearest neighbor. And for this, you need to look at one video. Now, before going into that video, I just want to explain it. What is it? And then you can go to, you may watch that video. Okay. Shaunak, I will just repeat side by side. There is one drive link. 2 files are already there. So I'm just sharing that drive. No, it's not a drive link. Can anyone share it for me? It's for Shaunak. Okay, please share the drive link once again. Any one of you. Yeah, thank you so much, Hitesh. So you can download 2 files from here, Shaunak. Okay. Right. Thank you so much. Okay. What is this KNN? KNN is K nearest neighbor. There should be some picture over here. Just let me see if that picture is there. This is just the structure of the flower. Okay. So you can understand more about the data set from here. Right now, I don't need this. Okay, what happened? For example, let me open some document, then only I will be able to explain you. Let me open Paint itself, no problem. Okay. KN is related with CSV. I'm just coming to it. Don't worry about it. Just give me 1 minute because I want to explain you KNN first so that you can later do it. Let me increase the screen size. Very small size it's showing. Let me increase the size. Okay. Now, what I'm trying to show you here, for example, we have some red color balls. Okay. I want a filled one. Okay, let's work with this only. Fine. It's something like this. And then let's have some blue color balls. Okay. Fine. Now let's have the ball, which these are, you can say it's a data points. Let me complete. Okay. Then I will come to you. Now let's have some ball. I want to predict its class. I really don't know whether it belongs to a red class or it belongs to a, let me change its color, green. Okay. Now I just want to predict the class of this green one. I really don't know whether it belongs to red one or it belongs to the blue one. Okay. Now, for example, I'm making an oval for it, something like this. So in its nearest neighbor, we have one red and one blue. So can we able to understand whether its features are more near to red one or more near to blue one? No, it's very difficult because it's near to one red and one. Okay. Now let's change my circle and this time make it something like this. Okay. Now how many blue balls are there near to this green one and how many red ones are there? Anyone? How many blue are there and how many red are there? Any idea? One blue and two red. So there is a more possibility this belong to which class? Blue class or a red class? Anyone? What is a red class? Okay, because near to it we have two balls which belongs to red class. Okay, so how many previously how many neighbors we have considered? Just two neighbors. This time how many neighbors we have considered? How many neighbors we have considered? Three, right? Now let's expand it and this time you do it something like this. Make it something like this. Okay, or let's take the all. Let's take the all. Okay. In reality, we have a lot of data points. Okay, right now, just for example's sake, I have taken very small. So here, how many? 5 blue are there and 3 red are there. So we will come to a conclusion. Most probably, this green belongs to which class? Blue class. And this time, how many neighbors I have considered? How many neighbors I have considered? Blue is having the majority, right? And how many neighbors I have considered? I think 3, 4, 5, 6, 8. 8 neighbors. Exactly, Shiva. Okay. So you got some basic knowledge. What is this all about? K nearest neighbor. So whatever the class or whichever flower I want to predict, I will just compare it with the neighbors around it. Okay. Just give me 1 minute. Let me close this window. Okay. So are you ready to view this video? Once you understand the concept, then I will tell you how we can code it. Then here can we conclude with accurate and inaccurate data? There are so many ways of finding this accuracy. We also have to find out how many neighbors are more appropriate to be considered. So that also we will discuss. So don't worry about it. Okay. So let's see, where is that video link? Don't ask for the annotation, guys. Okay, just let me check where is that video link. Give me a minute. And then I will explain you the code over here, right? Yes, here is the video. I think I have to share my screen once again because I have not shared the voice. So let me share my screen once again. Give me 1 minute. Just give me a minute.
And welcome to another fun and easy machine learning tutorial on k-nearest neighbors. In pattern recognition, the KNN algorithm is a method for classifying objects based on the closest training examples in the feature space. KNN is a type of instance-based learning or lazy learning where the function is only approximated locally and all computation is delayed until classification. The KNN algorithm is fundamental and one of the most simplest classification technique when there is little or no prior knowledge about the distribution of the data. The K in KNN refers to the number of nearest neighbors that the classifier will use to make its prediction. Please smash that subscribe button and click that bell icon to join our notification squad. Let's take a look at how it works. To get a clear understanding of the KNN algorithm in action, let's look at a Game of Thrones example. Say we want to train an algorithm to automatically classify if an unknown person is either a Dothraki or Westerosian. You can use two features to help you classify or predict which clan the person belongs to. So for example, we can use muscle mass and wealth, treasure net worth, or riches as the independent variable or features. So for the bulk of the Dothraki, let's assume they have a higher muscle mass as they are nomadic warriors. People from Westeros, however, let's assume they are a wealthier population and urban dwellers, so that the average muscle mass would be significantly lower than that of a Dothraki. So looking at our unknown person, we measure up their treasure as well as their gains. We place them around about here. And using k equals 5, we draw a circle until we have 5 neighbors in the vicinity. Now using nearest proximity, we can see that this person has 3 neighbors that are Dothraki and 1 neighbor that is Westerosian. And thus using majority voting, we can classify that the person is Dothraki. Now we don't need to use muscle mass or wealth. We can use other features such as height, waist, skin and hair pigmentation, eye color, amongst others. So the crux of the algorithm is to ask, who are my neighbors and what class do they belong to, and how many of those neighbors of a particular class are closest to me, and I will be the same class as the majority in my proximity. If we take the second example and draw a circle around here, we can classify our unknown to be a Westerosian based on majority vote. Quite simple and easy to understand. It is important to note that k should always be an odd number to avoid a draw in the votes. Proximity metrics. Mostly Euclidean distance is used for KNN, but you can use other distance metrics such as Hamming distance, Manhattan distance, also known as city block, Minkowski, and Chebyshev distance, amongst others. So if you look at
So are you, maybe it's lagging certain time. Am I audible? Am I audible now? Okay. So maybe in between it is lagging, but you have the link with you. Many students already shared in the chat section. So you may look at the video once again later, right? So I hope the concept is clear to everyone. They have taken a very complex example. Mine is a simple one. I hope all are agree. Yes. Okay, but they have the better graphics. So that's why I've shown you this video. Okay. And if you look at the, online resources, there are so many better examples out there. So you can always look for it. Okay, so can we start with the coding? Yes. So we have done right now two things. I have uploaded my data set, which is iris.data. And second thing is I have imported one file. And what was that? What was the file that I have imported in the beginning? Should I show you? Pandas, exactly, Isha. Okay. Now let's move further. So the first thing that I want to do is, I want to, just let me check. Okay. The first thing is I need to read the CSV file. This you may have done earlier also. We don't have to go into dashboard detail, Hitesh. That's why I close the video there and then, right? First of all, let's do the coding. And then if some complex things are there you want to know, I can explain. Fine. So one thing is df is equal to, I want to read the CSV file. This you must have done earlier also. So I have shared my link in the Google Colab, and this is the link I have put over here. For you people, if you are putting it in some folder, so you have to give the complete path over here. If your IPyNB file, that is your notebook, and your data set is in the same folder, so you just need to write iris.data. That's it. This is not needed. Okay, but if you are working in Colab or you have saved it in some other folder, then you need the complete path over here. Okay. Now here what I am doing, you people must have noticed in my data set, there is no headers. Column headers were there. Have you noticed? The column headers were there. Anyone? Yes or no? Am I not audible? No, no header is there. Yes, exactly. So I have to give some header to my columns so that it becomes easy for me to understand, right? So this is one list I have created. List you must have done earlier. And I have inserted some headers over here. And what was that? Don't give the answer right now, Siddharth. Let everybody try it. Sepal length, sepal width, petal length, petal width, and the last one is class. Okay. Now, what I am doing? I am adding all these names as columns. So I have created a data frame. What is the name of my data frame? DF. Okay, so right now physically it is there in some folder, but I have uploaded it into the memory. And yes, df.tail is for the last 5. I will come to it, Ritesh, don't worry. So we have created a data frame, and in this data frame, I have loaded my data set iris.data. Then I created a column names list, and then I have added that column name to my data frame. And then I have printed the first 5 rows of my data set. Any problem in this code? Anyone? Any issue? Yes, do it in the notebook, not right away. I will give you some time to execute. Right now, you just understand. I will give you some time where you can execute. Okay. Header equal to none means in my data set, there is no header. Okay. So this much is clear to everyone. Now, the next thing is setting up the data for KNN algorithm. Okay. Have you people done label encoding? Any one of you? In the previous session, label encoding? No. Okay. So we all understand that at the end, the machine understand which kind of data? Numeric data? In numbers, no problem. I'm explaining you. So in a result, it will give you the numeric output, right? So what does it mean? These classes are in textual form. So I need to convert it into which form? New numbers. I need to convert it into numeric forms. Okay. Yes, numerical. So for that purpose, there are different ways of doing it. The first one is label encoding, and there is one more that we will also do, and that is hot coding. Okay, that also I will show you. So let me show you the label encoding first. Quantitative, why you are asking quantitative? Yeah, we want to convert it into quantitative. Numbers, I am converting it. Okay. So first of all, let's see. I want to count from each class. Do you people notice how many total rows are there in my iris data set? Any one of you, have you noticed how many total rows are there? Any one of you, giving you a minute. Just check and tell me. We can do it through Python coding also, but otherwise it's a very small data set. 150, exactly, Siddharth. So, no, it's 150. Okay. So, I just want to check how many data points are there that belongs to each class. Yeah, it's okay, Hitesh, no problem. Right. So, first of all, I'm doing a label encoding. Before that, I'm just counting how many total data points are there that belongs to each and every class. So for this, what I have done, I have written print df class dot value underscore counts. Now can you see what is the output that is giving me? It is giving me the output iris setosa 50, iris versicolor 50, and iris virginica 50. So in total, it contains how many data points? How many rows? 150. Okay, I hope this is clear. Now I am doing the label encoding. For doing the label encoding, I am creating a kind of dictionary. Dictionary is another kind of data set that we use in Python, right? Like list, like sets. So similarly, like NumPy arrays, we have dictionary also, right? How we do in dictionary? I'm giving a name to which column? Class column. Yes, we use curly braces over here. Now I am doing a coding where I am allotting 1 to which class? Iris setosa. I am allotting 2 to which class? Iris versicolor. I am allotting 3 to which class? Iris virginica. Okay, I hope it's clear. Okay, so I have created a dictionary. Now I have to put these label encoding into my data frame. So for this, I use which function? I use a function df dot replace. What I'm using? df dot replace. Then I will write down the name of my dictionary. In place equal to true, it means I want to actually put it physically over there. Okay, so that's why we write in place equal to true. Now I want to count how many data points are there in each class. And now my classes are 1, 2, 3. Now my classes are, ma'am, is the first statement. What should we write? The same thing, I will copy it in the chat section. Don't worry. Let's just understand it first. That is very, very important. Execution you will be able to do. I know that. So now can you see? Iris setosa is replaced by 1. Iris versicolor is replaced by 2. And iris virginica is replaced by 3. So is the label encoding is clear with everyone? Is the label encoding is clear? Prahlad, are you able to understand? Okay, okay. That's great. Now let me copy this. Is it there in your notebook? Is this code there in the notebook? Okay, it is there. Fine. If it is not there, I'm just copying it and pasting it in your chat box. Okay. Now I'm just giving here a 2-minute break. It's not a break, in fact. You just tell me when you all are able to do this much. Okay. If you all are able to do label encoding, please type a message or you can show a thumbs up also. That will also work. So right now we have not done any modeling. We have just done a label encoding. Right now, okay, Ishan has done. Right now I'm telling you label encoding. Then I will tell you one hot encoding also. Ma'am, I'm getting a key error class. Just try it, Shaunak. Otherwise, at the end, we will just, I will just share, get your screen shared. Okay. Just give me 1 minute. Just do it quickly. You have one more. Okay, are you all able to do? You got stuck. What is the error that it is giving you, Bhave? What is the error? In place is equal to true means it is actually physically going to add the column headers over there in the data frame. Okay. Class not defined. Okay. This class, have you written over here? Have you written this class over here? Or maybe you missed something here. Have you written this class? First of all, you need to do this and then the next one. I'm just copying this code also. I'm just copying this code also. Okay, first of all, you need to do this. First of all, you need to execute this code. And then I'm keeping that code once again. And then the next one. Now just check, are you able to do? Just check, are you all able to do? Just copy paste the code. Don't type it right away. What is df.head? This you have done earlier also, Akanksha. df.head, it print the first 5 rows of your data set. And if you want to print the last 5 rows, instead of df.head, you can also write df.tail. Okay? Yes, Shaunak, exactly. And if you want first 10 rows, then you can also write a number in df.head. Okay, for example, here you can specify a number. For example, I want to print 10 rows. So you can also print 10 rows. See, now 10 rows are there. Yes, Shaunak. Are you able to understand now? Should we move ahead? Yes. Should we move ahead? Yes. Okay, great. So right now we have done this label encoding. Okay. So here also we have done the same thing, whatever we have done earlier. Now there is one more method. Let me explain you that method also, and we call it as one hot encoding. Are you able to see? One hot encoding. Okay. In this, what it do? It tries to convert it into binary form. Okay. For example, you have 2 columns. Okay, here one example is given. You have 2 columns, which is showing rainy and sunny. Okay, if it is rainy, whatever error is coming, we will check it later. Okay, we will check it later. Now, for example, rainy is as first position and sunny is at second position. If it is rainy, so rainy will be 1 and sunny will be 0. So what is the code for rainy? 0, 1. And if it is sunny, what is the code? If it is sunny, what is the code? 0, 1. Yes. Because in the first column, we are representing rainy. In the second column, we are representing sunny. So if it is rainy, my first column will be 1 and second will be 0. So the code will be 1, 0. Okay. Now, can we add one more kind of season to it, weather condition to it? Overcast, for example. So I'm having rainy, sunny, and overcast. Okay. Now here, if I want to show rainy, what will be my output? I want to show rainy, sunny, and overcast. Anyone? Okay, let me explain you. Let me open something. Let's open Word. so that I can type and explain it to you. No, it's not 102. It's wrong. Just give me a minute. Yes, I'm explaining it once again. Okay. Now, for example, I want to show rainy, comma, sunny, comma, overcast. Okay, right? This is my 3 columns. Now, my season is, right now, my weather condition is rainy. So, how I can denote rainy? 1, 0, 0. Okay? Because it is rainy, the first will be 1. It is not sunny, it will be 0. It is not overcast, it will be 0. Okay? Now, next one is sunny. Can anyone tell me now what will be the code for sunny? Whatever error is coming, we will discuss it later. This is something very important. Please listen here. Sunny. It's not rainy. 0. Second is sunny. Yes, it is sunny. Make it 1. Next is overcast. It is not overcast. Make it 0. Last is overcast. How I can write overcast? It is not rainy. Make it 0. It is not sunny. Make it 0. It is overcast. Yes. So are you able to understand this coding system? Yes? Okay. Now let's do it for Setosa. How many kinds of flowers we are having here? Setosa, versicolor and virginica. Okay. So for Setosa, what it will be? For Setosa, 1, 0, 0. Very good. Let's give some space between it. Okay. What about second type? What was the second type? Second type is versicolor, na? So, oh, okay. So for versicolor, what will be the code? For versicolor, the code will be 0, 1, 0. And the last one that we have is virginica. So for virginica, what will be the code? 0, 0, 1. Okay. So it's clear to everyone. Okay. Now I'm just giving the code for it. Okay. And you try it. Just give me 1 minute. Okay. Give me a minute. Let me give you that code. Okay. I'm just facing some technical issue. Let me copy this code. I'm not able to copy it. So I just restarted it. Just give me 1 minute. Just give me a minute. Okay. Yes, I got it. Okay. So for this purpose, do not change your original data frame. Let's create one more data frame. And in that data frame, this is a code for one hot encoding. Here. Is my screen visible? Yes. So this is how we do df2.pd.getDummies. Okay. And we are doing it for which column? Class. Now it is showing me a lot of errors because I have to get the path again. Yes, this is the path. Please take care of your path. Due to path, it will give you a lot of error. Okay. Now I need to, because I'm working in Google Colab, so I don't need this path. I need the path that I have just copied and run it. Okay. So this is the way how it works. Okay. Right. Now here I'm giving you 2-minute break and please check, are you able to get the output or not? Now let me check the chat section and see how many of you are facing the challenges. After that, I will explain you the KNN algorithm. I will explain you the KNN algorithm and then decision tree will be your homework. Okay. Now let me check the chat. Please send the message if you are facing any issue. Don't send the output. If any challenges anyone is facing. Yes, exactly, Ishan. Your data set and your file should be in same folder. Let me show you. Can you see here? I have a folder with the name day 7. Now this is my data set and this is my notebook. They should be in the same folder. Okay. Are you able to get this? And when you write here, you only write iris.data. This content is not needed. Content one is only needed for the people who are working in Colab. You got this answer. Very good. That's great. Excuse me. Just show me the thumbs up, those who are able to do this much quickly. That's great. Lakshita has done, Siddharth, Shaunak, more people. Let's see how many total participants are there. We are having around 115 participants. Yes. Done. That's great. Okay. So are we good to go? Or you need a break of 5 minutes right away or after 10 minutes? Are we good to go? Yes. Okay. So let's move further and let's see how we can apply the KNN algorithm. Once I will explain you, then I will give you around 15 to 20 minutes to execute it. Okay. Okay. Levin is having one doubt. Please type it, Levin. Anyone else also, if they are facing some issue, please write it right away. Quickly write it. Let me check what error you are saying. Okay, it is some version issue. Yes. Nothing you need to do for this. You can do one thing. You must have told with how to create an environment. Okay, so instead of just removing something or changing something, you create a new environment and do in that. Okay, so that can be done. Okay, don't deprecate your libraries. Just create a new environment and there you can work. Okay, because a lot of changes are there that is happening every day. So that's why. Okay, anyone know what is scikit-learn? What kind of library is scikit-learn? Have you heard of scikit-learn? Anyone? Yes? No, it's a machine learning library. Exactly, Ishan. Yes. So now we need for creating a AI model using KNN, we need something from the library called scikit-learn. Okay, and how we import k-neighbor classifier from it? By using a statement from sklearn.neighbors import k-neighbor classifier. Okay, I'm just copying it in the chat also, but I think it must be there in your notebook as well. Yes, is it there? Yes, is it there? From sklearn.neighbors import k-neighbor classifier. Okay, if you want more information about scikit-learn, you can click over here. So this is the code that you can do. Okay. Yes, so many learning popular, AI algorithms. Like we will do one more decision tree also we will do. This is done. Now let's see. Okay. Now, when you are creating an AI model, just understand three different steps. Yes, random forest also. Three different steps are there. The first one is you will initialize a model. Okay. No, it's reinforcement is not there. The first one is, you may check also, Ishan, right? The first one is you have to initialize a model. The second one is you have to train a model. And the third thing is you have to test the model by using the dot predict method. So basically three methods we are using over here. The first one is dot fit. Dot fit is used to initialize my model. Okay. Then we have, to train my model. This is how we initialize our model. Okay. What is my library name? K neighbors classifier. So I create an object of K neighbor classifier with the name KNN. This is just like a object name or a variable name. The way we keep the variable names. So it is like a object name. Okay. Yes, Siddharth. So first of all, what we are doing, we are initializing here. Okay. Now we all know there are features. Okay. One are dependent feature and one are independent feature. Do you have any idea what is the difference between dependent feature and independent feature? Anyone? Anyone having any idea? Dependent features and independent features? No? You don't know, Vishesh? No one. Okay. Okay. Now, if I ask you, what is your total percentage? Now, your total percentage depends upon what? Your total percentage depends on what? I'm asking you, what is your total percentage? Calculate it. Okay. So, this total percentage, what you need as an input to calculate your total percentage? Anyone? You need marks in each and every individual subject. Then you create a total, calculate a total, and then you find out the percentage. So your marks is your dependent variable, independent variables. Your marks is your independent variable. And depending upon the value of these features, you are calculating your percentage. Your percentage is dependent. Exactly, Rudra. Okay, are you able to get it? Now here, which are independent features? Here, which are independent feature in my data set? You can't do anything for it. वो जो है, वो है. You can't do any changes to it. So you have sepal length, sepal width, petal length, petal width. So all these are independent. Depending upon these features, your model is trying to predict your class. So your class is what kind of feature? Dependent feature. Exactly. Let's see who has written this. Very good. Okay, Gaurav, Rudraraj, very good. So now you are able to understand. So we have to create one data frame, which we call it as X. In the X data frame, we will put all the independent features. Right now, I'm just considering two, that is sepal length and sepal width. And one which is dependent, that I'm keeping it in Y. Okay, and from this data frame, I'm taking what? I'm only taking class. Okay, so I have created two variables. One is X, which is independent, and what is Y, which is dependent. Okay, now let's print their first 5 rows. They are actually two different data frames, nothing else. Let's print. Now, can you see in the X, it is printing the first 5, and in the Y, it is printing the next 5. Right? So this is clear how we have made X and Y. Now the next thing is we have to train our model. Right? To train our model, we use a function dot fit. What we are using? We are using a function dot fit. So what I am doing, knn equal to knn dot fit, and then I pass my dependent variables as well as my independent variable, that is x comma y. Okay? So we have trained our model. Now what is the next step? I have initialized my model. I have trained my model. Now what is the next step? Anyone? Testing. Yes. And testing is done with the help of which function? Model dot predict. Model dot predict. Okay. So for this, I need some new data. No? I don't want to take the data set which is already there. So I need some new data, some new values. So for this, I am creating two different lists. Test sepal underscore length, and I am keeping two values 5, 8. Okay, how many data points I am giving for the testing? 2. And again, I am giving two different sepal width. Okay, and then I have passed these values to my knn dot predict. I have passed these values. Okay, you can give anything. You can give any data. You can change these values. But at least keep it real values, which is very near to the values which are already there in the data set. Okay, you can give 3 values as well as. You can give a complete another CSV file also. Okay. So I have done this and then applied the dot predict function. And let's print the result. Now, can you see? This is my testing data set 5, 3, 0, 8, 3, 5, and this is my result. Are you able to understand the result 1, 3? What does the 1 is denoting? Anyone? My output is 1. What does it denote? Which class? Which flower? 1 is which class? Which flower? Setosa, exactly. I have done the label encoding. So one code I have given to Setosa. So this is 1. Okay. And for the next one, what I have done? 3, that is Virginica. So this is my output. Okay. This is my output. So that I can compare with the real values and I get to know. There are ways to calculate the accuracy also. So that we will discuss later. Okay. Yes, Rudra, please write your doubt. So I hope this is clear. This much is clear to everyone. This whole thing. Yes. So I'm giving you this whole code. Please write down your doubt. I'm just waiting for it. Okay, there was one doubt. Now let me check. What is it? You have not written the doubt, Lakshita. What can we do to get 1, 2? See, the answer is coming depending upon the values that you are giving it to it. Okay. So you can check for some values like you open this one. What is the second one? It's versicolor. Now just check the values of versicolor. Sepal length is between 6, 7 and this is between 2, 3. So try to give some values around it and then see, are you able to get 2 or not? Yes. Okay. So now let's have 5-minute break. Yes, use iris.data. Okay. Okay. sklearn is not there, then please do pip install sklearn. You all know now, you have installed your pandas, your numpy. Yes. So same way you can install sklearn also. Okay. So let's have a 5-minute break. Okay. And then one more thing you can do. Right now, I have considered how many independent features? How many independent features I have considered? 2. But how many features do we have exactly in my data set? How many in total? No, not 7, Rudra. We have total 5 columns. How can you say 7? Okay, Lakshita got the output. How many independent features are there? Check the data set. How many are there? Total are 5. How many are independent? Sepal length, sepal width, and petal length, petal width. 4 we are having. So try the same code, but this time, in addition to sepal length and sepal width, you will take also petal length and petal width. And try the same code. And then see what kind of output you are getting. Okay. And this is the values that is being taken for the testing. Okay. So let's have a 5-minute break. And then right now it's 5:13. So we will be back by 5:18 after 5 minutes. Okay. In between, try the code also. Are able to do with the 4 data features? Sepal length, sepal width, petal length, petal width. Is anyone able to do? Okay, Rudraj has done. So this is the code. Okay. You have to increase 2 more features over here. And this is how they have tested. And what is the result this time coming? Anyone? Can anyone interpret this result? 2? Someone was asking me, ma'am, why 2 is not coming? So this time it is coming 2. 2 means which flower? 2 means which flower? Anyone? Versicolor, exactly, Rudraj. So do anyone of you want me to copy this code and give it to you? Yes, anyone? This I have not executed, so that's why, but it's the same thing that I have executed earlier. Okay, you want. Okay, great, great. This one now. So here I have initialized one more model. The name is KNN2. Okay. And once the model is trained, then I'm testing it with this data. It not at all compulsory to keep this data only. Try to change the values and see what effect does it have on the output. Yes, are you able to check? You can do. Can you print the name of the flower instead of 1, 2, 3? It's something very simple. You simply have to use if then else. That's it. Yes, you simply have to do if else. You write if else, if the answer is whatever answer is, it is 1, then print setosa. If it is 2, then print this. Okay, if any one of you have done, then please do and paste the code in the chat section. So the flower is versicolor. See, Siddharth has done something. Oh, that's great. That is also another way. Otherwise, simple way is you simply use if else. Some error. It's a very big error. Just tell me the last line of the error. That actually tells sepal length and sepal width. It is giving an error. some code is missing. Okay, at the end, I will share this notebook, coach notebook with you all. So don't worry. Some code is missing where you are supposed to write sepal length and sepal width. You can use if elif. Yes, you can use. That's what I'm saying. So you will be able to print the name of the flower as well. Okay. So try to do this second one also, where instead of 2 features, we have used all the 4 features. I will upload this notebook in the drive link also. Don't worry. If you want it right now, I can do it right away. Now, should we start with decision tree or you want me to wait for another 2 minutes? Okay, you have another 2 minutes. Please try it and then we will begin with the decision tree. Let me open one figure that we need. Just give me a minute. One minute. Okay. So I'm beginning with the decision tree. Is my screen visible? Are you able to see one tree-like structure? Yes. Are you able to see one tree-like structure on the screen? Yes. Okay, great, great. Okay. Now, what happened whenever we want to take some decision? My decision always depend upon certain. Anyone? How we take any kind of decision? Can we take all the decision randomly? No. We need something to take that decision. Conditions. Exactly, Siddharth. So we need certain conditions, and depending on that condition, I take my decision. Everyone take their decision. Okay. So here, if you are able to see the screen, yeah, some criteria also we can say, Varnika. Exactly. So here, if you look at the screen, you can see the person want to decide. What the person wants to decide? You only tell me here what kind of decision a person wants to make. Anyone? What kind of decision? Just look at this decision tree. What kind of decision? Whether to do the exercise or not. And it depends upon which condition? It depends upon which condition? Weather condition, exactly. Okay. So right now the person is taking into consideration only 2 conditions, whether it is sunny or rainy. If it is sunny, then again it is asking, is there any possibility of rain in the next 30 minutes? If the possibility is high, then what will be the intensity of that predicted rain? If the intensity is high, very heavy, so then my result is do not exercise. If the intensity of predicted rain is light, then a person can exercise. Similarly, just move above. Possibility of rain in next 30 minutes, it's very low. Let's exercise. Okay, now let's go to the right part of my decision tree. If it is, yes, exactly. If it is raining, sometimes not only true and false, sometimes it depends upon certain value also. Like if salary is greater than this, if marks is greater than this. So this can also be there. Okay. So here, intensity of the rain. If the intensity of rain is very heavy, then we already know do not exercise. If intensity of rain is very light, then again, I will ask, is there a possibility of rain that will stop in the next 30 minutes? If this possibility is there, then I will exercise. If there is no such possibility, then I will do not exercise. Okay. Now this is the decision tree. Here there is some terminology you need to understand. These are the different branches. What are these? These black ones, arrows are different types of branches. Okay, and why we are calling it is like tree? Because it's just like an inverted tree. Isn't it like an inverted tree? Where the root is at the top. So here, this weather is at the top. So this is my root. So whether we call it as root, right? And all these lines which are actually, showing my decisions, my actions, these are all branches. Okay, and where I actually took my decision, we call it as leaves. Ye last one, the last one, all these we call it as leaves, right? Okay, we have learned about this in the lesson flowchart. Okay, but this is not a exactly same like flowchart that we do in the programming, but somewhat like that. Okay, so this is all we call it as decision tree. So this can be, this is also a model. Okay, we can create an AI model using this decision tree. Okay, there are certain levels that we call it as a depth. Okay, like what is the depth of this decision tree? This is level 1, this is level 2, and this is level 3. So the depth of this decision tree is 3. Okay. So the concept of decision tree is clear to everyone. Is the concept clear to everyone? Yes? Okay, that's great. Now let's go back to the notebook. Excuse me. If you want more discussion about decision tree, then there is one video also. Okay. So you can get that video from here. It's showing a lot of lag last time also. So I'm not running this video. But I hope the phenomena is, the concept is clear to everyone. Is it? Yes? Okay. Now let's start with the code. Code is exactly same. The only difference is instead of k nearest classifier, okay, what we are using here? We are using here decision tree classifier. So I have initialized my model with dt is equal to tree dot decision tree classifier. The algorithm is different. No? That is the difference. The way of working, the concept is different. Okay, sometimes what happen, I want to do classification only and actually don't know whether I should go for KNN or I should go for the linear regression. Sorry, I should go for the decision tree. So I'm not aware of it. So what can we do? We can we can create different models. Then we try to find out the accuracy. So I will go for the model which is having the maximum accuracy. Okay. The random forest classifier can also be used. Okay. So these are the different types of models that we can use. Fine. So again, right now, how many features I'm using? 2 more features initially. Which is more preferable, I told you, na? It depends upon the accuracy. You try to find out the accuracy. That will come later. You don't worry about it. Okay. We have an accuracy function. We will discuss about it later. Okay. So I created X, I created Y. This is clear to everyone. Then I printed X dot head. This is exactly same that we have done last time. Then I have trained my model. dt is equal to dt dot fit X comma Y. Please do this much. Everyone, do this much. Then I will show you how to do the predictions. Do this much, everyone. I hope everyone is doing along with me. If some are not able to do along with me, so I request them. Our testing also we will do, Varnika. So I request them, do it after the class. And if you face any challenges, we can discuss it tomorrow. Okay? Just show me the thumbs up. There are a lot of participants in this meeting. So why only 3-4 people are just replying? Okay, that's great. Prahlad, Rudraraj. Okay, Prahlad, why you're laughing? What happened? Ishan also done. Kamya. Okay. Hitesh also done. Good. Okay, no problem, Prahlad. No problem. So we have done. Are we good to move further? Okay. Now this is the way how we can do the testing. For the testing, I have created for the testing, I have created another DF won't be defined. That's why. For example, here I have not executed the code now. That's why it's giving me the error. I have not executed. I have to execute all the code. Then see, showing me the output. Okay. I have created another data frame for testing. And here I have put two values 5, 3. And then I have done the prediction. And what is the prediction? The prediction is Setosa. Okay. Let me copy this code and give it to you so that you can also execute. I think for this code I have copied in the chat section. This one. Have I copied this one? Can anyone help? Okay, Varnika said yes. Okay, now let's try with the second one. So here I have done the test. Okay, please do it. Once the testing is done, then do the same thing with 4 different features. Okay. So first of all, do this much first of all. I'm just sharing it in another 5 minutes. I want, first of all, you all should try yourself. Okay. And then I'm just sharing it with you all in another 5 minutes. In between, I'm giving you one task. Just try to find out different classification models that we can use. 2 I have told you, KNN and decision tree. Okay. Tell me 3 more or 4 more. You may Google, no problem. Tell me 4 more classification AI algorithms. Yes, I'm waiting for the replies. Those who have done, they can Google it. Those who are still doing, please first of all complete the code. Okay, let's see how many of you are able to get the answer. Okay, let's see. Naive Bayes, very good. Support vector machine, nice. Logistic regression, very good, Rudraj. Random forest, yes. So these are the different classification models. Okay, so once you are able to do these two, it will be very easy for you to do rest of them. So now you can understand creating a AI model is not a big issue. Of course, not very easy, but not a big issue. But what is more important? What is more important here? Okay, Hitesh has written something. The ethics of AI covers a broad range of topics within the field that are considered. I was reading something. Have you deleted that? By mistake. Okay, okay. I thought you were sharing some information. No problem. Neural network. Okay. So do you know tomorrow we are going to do the neural network? So get some basic knowledge of neural network so that you will be able to understand it in a very easy way tomorrow. Okay. Okay. Now I'm just sharing this next code with you all. Yes, Shaunak, very nice. So are you able to understand little bit machine learning? Yes. How happy are you by creating the first AI model? This is the first AI model that you have created. Okay. So your homework is below 1%. This is not possible, Siddharth. Your data set. Exactly, Shaunak. That's what I'm thinking. Achha, have you heard of the Titanic data set? Anyone? Have you heard of Titanic data set? Okay, have you heard of Kaggle? Have you heard of Kaggle? So when you go to Kaggle, there are a lot of data sets which are available over there. Okay, do you want me to open it? Let me open it. Okay, and I will share the link also with you all. Don't worry. So what is Kaggle? Anyone? Any idea? What is Kaggle? Kaggle is a AI and ML community. Yes, UCI website also. That is also very popular. So here you will get number of data set, number of projects. Okay, if you are new in this field, so Kaggle is a website that will actually going to help you out. See, Rudraj has shared the Titanic data set. So I want you people, first of all, work with Iris dataset. Then you work with Titanic dataset. Okay. You work with Titanic dataset and try to use KNN in that. Try to use, decision tree in that. And tomorrow we are going to work with neural network. Now try to do neural network also. Right. And right now we are working with which domain of AI? Iris dot data. Which domain of AI we are actually working with? Anyone? We have three domains, all are aware of. We call it as data. All are ML, 11, all are ML. I'm asking statistical data exactly. So right now, in this bootcamp, we will work with the statistical data. Kaggle, you go to Kaggle only. Can you share the link of Kaggle, sorry, Titanic dataset once again? See, Rutraj has shared once again. Yeah, it is there in UCI also. These are some common data set. It's there in UCI also. Ritvik, okay, let me share this notebook with you all so that you can execute it. Just give me 1 minute. Let me upload it in the drive. Okay, give me a minute. I have uploaded it on the drive. I'm sharing the drive link once again. Please download the notebook. Please download the notebook. And if you are facing some issue, you can ask me. Execute all the code. Okay. Are you feeling some attendance link also every day? Yes. But I don't have that attendance link with me. Niranjan sir, do you have any attendance link with you? Okay, let me check if I am able to get the attendance link. Model accuracy is 80%. That's great. Who is the host? Navneeta Niranjan. Are you a student? Okay, okay. You are a host, na? That's why. Please make me host. Navneeta Niranjan, please make me host. Okay, thank you. Thank you so much. Okay, just execute the code and I'm trying to get the attendance. Give me 1 minute.